Alright, so we've been able to figure out how to find angles and sides of right-angled triangles using trigonometric functions. But now we're going to explore a few rules that we can use for when the triangles aren't right-angled, right? So the first rule we're going to learn is the sine rule, and this dictates that sine A over A equals sine B over B equals sine C over C. Right, so and another way of writing this is we can flip all of them, so we get B over sine B, C over sine C. Now you might be wondering what these letters mean. Well, if we get a triangle, remember it doesn't have to be right angled now. If we take a side, it doesn't matter which order these sides are labeled, so A, B, and C, it doesn't matter which way around they go. The only thing that we have to do is label the angle opposite the side. We have to label that with a corresponding letter, but the capital version. So the lowercase a dictates this side, so the opposite angle should be a capital A, and same with B, same with C. Right. So now that we know what each of these mean, we know that the capitals are the angles and the lowercases are the sides. Now, I've given you two equations here. I'm going to tell you this is the equation when you want to find the angle. This is the equation when you want to find the side. Or the length, I guess. It doesn't really matter which one you use, you'll still be able to get to the answer either way, but it makes it easier when you choose the correct one if you want to find the angle, the side. Just basically the thing you want to find should be on top. Alright, so let's do an example. Right, so here we have a non-right angled triangle. We have this angle 35 degrees, and this angle 21 degrees. This is 23, this is x. And then it would say find x, right? So, what we need to realize is when we should use the sine rule. And we can use the sine rule when we have two corresponding sides of one pair of a side and an angle. If we have that, we can figure out other corresponding pairs. So what I mean by that is that we have a pair here, this opposite, right? So what we can say is if we label this side A, this would also be A, right? If we label this side B, we could label this angle B, right? We still have these opposites. So now what we can do is, because we're finding the sides, let's use this equation. So we can put down A over sine A equals B over sine B. We don't need to put the C down because the C, we don't really care about the C, so we don't care about this side or this angle. So yeah, now we can start filling in our values. So we have 23 over sine 35, and then we have B, which is x, over sine 21. Now you can see if we times both sides by sine 21, we get, bring it over here, we get x equals sine 21 times by 23 over sine 35, like so. And now if you put that into your calculator, you will get sine 21 times by 23 sine 35. You'll get the side length to equal around about 14.4, right? And that will be your length of x. Now, just if you realize what we've done here, and the way you can spot when we can use the sine rule, is if we have a pair like this that we already know. So we know that side A and angle A. If we know that, we can figure out the side to any other angle we know, or the angle to any other side we know. So let's do another example. Okay. This time, and here I'll introduce something they might trip you up with. Actually, that's very small triangle. Let's do this. Yeah. Bear in mind, this isn't a right angle, as much as it looks like a right angle. So yeah, let's say this angle is 35, this is 25, this is 43, and this is x. Okay? We want to find x. Find the obtuse, find the obtuse angle x, right? And remember, an obtuse angle is just one that's between 90 and 180 degrees. Okay, so let's use the sine rule again. So let's label our sides. I'm just gonna label the ones we know with A, so this will be A and A, they're opposites. And C, because we know this pair, right, that gives us one side of the equation, and now, because we know it's this side, we can figure out this angle. That's how it works. And also, we're going to use this top equation because we want to find the angle. Okay, so let's do that. So we've got, oh yeah, also we want to label this as B. Like so. Okay, so what we can say is, first off, let's say sine A over A equals sine B over B. And what we can do is we can fill in our values, so we get sine 35 over 25 equals sine 43 over sine x, sorry, because we don't know the angle, over the side 43. Now all we need to do is times through by 43, so we get 43 sine 35 over 25 equals sine x. And now you can see that we actually haven't got x by itself, which is what we want. But we can use a trick we learnt last time and apply the inverse sine function on both sides to get x equals the inverse of all of this. Okay, and if you put that into your calculator, you get 80.6 degrees, right? But remember, this is not obtuse. This is an acute angle. It's less than 90 degrees. So we have an issue here because it wants the obtuse angle. So what we need to, and what, if you want to know why this is the case, if we have a triangle, there is always, if this is an isosceles triangle here, there's always gonna be an isosceles triangle here with where this is 25, and because they're the same length, this is 25. So you'll have the same length but two different angles. So we actually need to figure out which of these angles it is. And to figure out the proper angle, all we do is we do 180 minus 80.6. Because that'll give us the non-acute angle, which will give us 99.4 degrees, like so.